Can I call Zachary Lang? Will he be here, please? Are the judges ready?
Did you know, on average, you need to mine 1 ton of rock to find a diamond, and that only 1 in 10 diamonds are actually pure quality? So that means to find a diamond suitable for an engagement ring, you have to mine 10 tons of rock. That makes looking for a needle in a haystack a pretty enticing endeavor in comparison. It also means that diamond mining, which is an important part of the Canadian economy, is tricky and expensive. To combat this, the miners have started to use X-rays to recover diamonds. Now, this may conjure images of airport security scanners or equipment used in dentistry. What they're actually looking for is for the diamonds to light up when they get excited by X-rays. So diamonds light up, the rocks do not. They can be easily distinguished and sorted out. Sounds simple, right? Unfortunately, it's not quite that easy, because some diamonds won't light up when exposed to X-rays. The reason for this phenomenon is not well understood, and science currently can't predict which diamonds will light up and which ones will not light up. This is an important issue for Canadian diamond mining, because some of the deposits have very large populations of diamonds that won't light up. And often the difference between a mine being profitable or not comes down to recovering those diamonds. Recently, however, technology has been established that can measure X-ray penetration response and relate that back to atomic number. This means you can scan a particle and determine whether it is a diamond or a rock. You can visualize this in the bottom left-hand corner of my slide. That material has been scanned with an X-ray and then the response recorded. The material that is red and blue has a high atomic number, and the material that is green, in this case diamonds, has a low atomic number. The only drawback to this technology is there hasn't been a study to comprehensively examine diamond characteristics and the response on X-ray penetration. My research aims to answer some of those questions. So what I did was take diamond characteristics, X-ray penetration response, and X-ray light-up response, and then examine them to see if there was a relationship. What I found was X-ray light-up response varied inconsistently between diamonds and correlated very weakly with color, size, and diamond structure. Whereas X-ray penetration response was very consistent between diamonds and correlated very highly with the size and the weight of the diamond. What this means is that X-ray penetration technology can be used to reliably recover diamonds that don't light up. And that also means that diamond mining is more reliable, which means it can be more consistently funded into full-scale operations. Often the term diamonds last forever is used as a slogan to sell engagement rings. But what I want you to take away from this presentation is that with reliable technology, Canadian diamond mining can last the test of time as well. Thank you.